I tried to summarize the formulas that you'd need for sequences and series. So check them out here. You've got arithmetic and geometric. Remember, arithmetic is when you're adding a number, and they call that the common difference. Geometric is when you're multiplying by a number. They call that the common ratio. So we've got a recursive formula where you're finding the nth term using the term right before it, or maybe more than one term. But in this example, you're finding the nth term using the term right before it. So this is arithmetic because you're adding. This is geometric because you're multiplying. That's recursive. Now explicit means you don't need the previous term. And explicit is kind of nice because if you needed to find the 100th term, you wouldn't need to know the 99th term. You would just need to plug in 100 for n. Okay, so here's an example. Looks like arithmetic. And here's an example of geometric. Notice there's an exponent. This is supposed to be an exponent right here. 2 times 3 to the n minus 1. That's going to be kind of your giveaway that this is geometric. Formula for the nth term looks like this for arithmetic and this for geometric. Series means sum. It means I'm adding up all of the terms. And so here's the formula for an arithmetic series of n terms. And here's the formula for a geometric series of n terms. Again, the sum of all the terms. Those look kind of complicated, but you just got to pay attention and look up the formulas. I'm not asking you to memorize them. Just, find it. Infinite sum doesn't exist for arithmetic. Infinite sum for geometric is right here. All right, so let's see some examples. Find the common difference. So common difference just means how are we getting from the next term to the next term. Okay, it looks like we are subtracting 9, so the common difference is -9. Find the next 3 terms. Again, you want to kind of figure out what's happening. How do we get from number to number? +3. Looks like we're adding 3 to get to the next number, so then we would have, after 7 would be 10, and then 13, and then 16. +3, +3, +3. Find the recursive formula. So a recursive formula has 2 parts. It has the formula, which everybody knows is important, but you also have to pay attention to where we start. So when we look at these terms, we can see that we're subtracting 4. And so basically, the important part, the recursive part, says to get to the nth term, you just take whatever's right in front of it, the n minus 1 term, and subtract 4. And don't forget, you also have to pay attention to where we start. And so we would say A1 equals 27. You need both of those formulas, both of those equations to have a good answer. The explicit formula is a little bit different. We don't need the one right in front of it, so you won't have that an minus 1, but still it kind of starts the same. How do we get from number to number? It looks like we are subtracting 30. So the explicit formula, let's go back to the formulas again. Explicit formula for arithmetic is going to look like this, but it has to do with that nth term. You look at this nth term, a1 plus n minus 1 times d. That's what we're going to need. So we know the nth formula, or the nth term, is the first term plus n minus 1 times d. And so just fill in the different things that you know. You know the first term is -1. And we don't know what n is, so we'll just leave it an n. But d is that number right there. So times -30 here. The rest of this is just cleanup. We can distribute the -30. So we had -1 minus 30 n plus 30. And just look at your like terms. You're going to have an equals -30n. And then I see these like terms, -1 plus 30 is plus 29. That's the explicit formula. And what's good about that is if I want to find like the 100th term, I just plug in 100 for n. Find the term named in the problem, A35. Well, luckily we don't have a whole lot of formulas. We're talking about the nth term, so we know we're looking at this one. You do want to pay attention to whether this is arithmetic or geometric, and that comes with how do we get from number to number. It looks like we're subtracting 10 here. That tells me it's arithmetic, and so that tells me which formula to use. I know I'm using the nth term formula for arithmetic. I'm using the same one I just used. So an equals a1 plus n minus 1 times d. So we want to find the 35th term, a35. That's telling me that n is 35. N is 35, and so I can plug that in for n right here. But I also know a1 is negative 11. So negative 11 plus, if n is 35 right here, I'm going to have 35 minus 1, or 34, times the d number. D number was negative 10. So I've got all these numbers. I don't have a formula now. I'm going to have a number. I would just use my calculator here. Negative 11 plus 34 times negative 10. Negative 11 plus 34 times negative 10. Negative 351. So a35 equals negative 351. 11, find the common ratio. All right, common ratio is your hint that this is going to be geometric, but you can tell by looking at the numbers, it looks like we're multiplying times 5. So the ratio is 5. Find the 3 terms in the sequence after the last one. We'll just look at the pattern. Times 2, no, not times 2. It looks like it's times negative 2. So we're taking each number in that sequence times negative 2. So continue the pattern. We're going to have positive 32, negative 64, positive 128. Because I multiplied by negative 2 times negative 2 times negative 2 times negative 2. 15, find the recursive formula. All right, so if you go back and look at the recursive formula is going to look like one of these two, but it's important to notice which one we're looking at. Are we looking at arithmetic? Are we looking at geometric? So pay attention to the numbers. Times 4. It looks like we're multiplying times 4. So since this is a times, since this is a multiplication, this must be a geometric. So the recursive formula is going to look something like this. You take the previous term times the number. Previous term, in this case, times, no, not negative 4, just times 4. Like that. And then don't forget what we started with. We started at a1 equals 3. Next, find the explicit formula. Explicit formula is a little bit harder to come by, but it's more useful. Explicit for a geometric is going to look like this. And that's what we're dealing with. Maybe we should have checked that first. How do we get from here to here to here? Times 6. So look back at that explicit formula. Explicit formula looked like this. Number times number to a power. Or how about this? Look at your nth term formula. That's probably more like it. a1 times r to the n minus 1. an equals a1 times r to the n minus 1. So let's fill in what we have. A1 is this number that we started at. R is this number 6. And n, I don't know what n is. That's what's going to make this a formula. So we just say n minus 1. So the 1 is negligible there. We're just going to have an equals 6 times n minus 1. That's the explicit formula. What that's used for is if I want to find the 10th number, I would just plug in a 10 right there. Find the term named in the problem. So A12, we want to know, I guess we need to know if it's arithmetic or geometric first. So look at the pattern. Looks like it's times 3. That tells me this is geometric. So that tells me which formula to look at, right? Geometric, I want to find the nth term. It's going to be this formula, a1 times r to the n minus 1. So notice we're finding the 12th term, so we're finding a12 here. The first term is 1. And r is just this number times 3. Okay. So n minus 1, notice n is 12, so n minus 1 is going to be 11. We just need to do 1 times 3 to the 11th power, or how about 3 to the 11th power? Big number, 177,147.